Good morning, boys and girls. I'm going to be starting a math lesson.
Whoa, whoa, whoa. Sadie can't teach our math lesson today. You can help out though, maybe. All right, guys. So happy Monday or Tuesday or whatever day you are checking into this video. We are starting a brand new chapter in math this week. We are on lesson 11, chapter 11, lesson 1. And this chapter is going to talk about area and perimeter. You know what area and perimeter is? No. Okay, so Sadie's going to learn along with us. All right, so go ahead and grab your math books and open up to lesson 1. Why don't you go head off? All right. So our first lesson is talking about perimeter, and we're going to learn what perimeter means. And to help us learn perimeter, I have a fancy little song that I put over on the left-hand side of the page, and it is sung to the tune of The Farmer and the Dell. So I'll do my best to sing it for you, but it's going to basically help us remember what perimeter is and how to find the perimeter of shapes. So here it goes. Perimeter is around, perimeter is around. Oh, oh, don't you know perimeter is around. You add up all the sides, you add up all the sides. Oh, oh, don't you know you add up all the sides. Boys and girls, that is it. When we have a polygon shape, so that means it has to have straight sides, we simply just add the lengths of each side. So we are going to explore perimeter using what they call geoboards. Now, if we were in class, we would actually have these geoboards and rubber bands, and we would be building our own shapes, and we would count from one peg to the other as one unit. And we would see what kind of shapes we can make with our rubber bands. But since we're not in class, we have to make the best with what we have. So we'll just be using the dot paper that they have in our book. Now, it says you can find the perimeter of a rectangle on a geoboard or on dot paper by counting the number of units on each side. So it wants us to make a rectangle on the geoboard that is 3 units on 2 sides and 2 units on the other 2 sides. So if you remember what we learned about rectangles, 2 sides typically are longer, the ones that are opposite one another, and then the other 2 sides are shorter. All right, so we want 3 units on 2 sides. So I'm just going to start at the top and go 1, 2, 3. So I went the distance from one dot to another, and that's 1 unit. You can see that they showed that over here on the right. Okay, so that's 1 unit. So we need 3 units on the top. Then I'm going to go 2 units down. And then because this is a rectangle, I need to go 3 units across for the bottom, and then 2 units down the other side to complete my rectangle. So we have 3 units, 2 units, 3 units, and then 2 units. And they wanted us to write the length next to each side like I just did, and then add the number of units on each side together. So when we are finding the perimeter and we're at the point where we're ready to add up all the sides, it does not matter what order we add in. I might choose to do 3 plus 3 first because those are doubles, and then add the 2 plus 2 because those are doubles. And these might look like subtraction signs to you, but they are addition. Just when things copied, they get a little blurry. So 3 plus 3 is 6, and 2 plus 2 is 4, and 6 plus 4 is 10. So the perimeter of that rectangle would be 10, but we always have to have a label on it. And this time we don't know if it's measuring in inches or centimeters or yards or whatever. So we just say units, because from one dot to another is equivalent to a unit. So our perimeter is 10 units. It says, how would the perimeter of the rectangle change if the length of two sides was 4 instead of 3? So if our top and bottom, instead of 3 units, if they were each 4 units, and then the sides stayed the same, and they were 2 units each, how would our perimeter change? Well, since we added one more unit up top, and we added one more unit to the bottom, our perimeter would increase by 2 total units. Okay, so we could type that or write that down at the bottom here. Make it a little bit smaller. Okay, so the perimeter would increase by 2 units. And then to show that, it would be 4 plus 4 plus 2 plus 2. And when we add that together, 4 plus 4 is 8, plus 2 more is 10, plus 2 more is 12. Okay? All right, so before we move on any farther, I wanted to share with you a Math Antics video that talks about perimeter, because I think the gentleman in the video does a really nice job of showing what perimeter is and explains how to find it. So we're going to watch a little bit of this video before moving on.
Hi, welcome to Math Antics. In this lesson, we're going to learn about an important concept in geometry called perimeter. Perimeter is just a fancy math term that means the distance or length around a shape. But what exactly does the distance around a shape mean? Well, distance or length is a one-dimensional quantity that we can measure with units like centimeters, inches, or miles. That means that perimeter is also a one-dimensional quantity that we can measure with units of length. For example, the perimeter of a shape wouldn't be just 10, but it could be 10 centimeters. Or instead of being just 25, it could be 25 miles. The units are really important when you're talking about perimeter. Okay, but what exactly do we mean by around a shape? It seems like there would be a lot of different ways to go around a shape. Some of them would be short, and some of them would be very long. Well, perimeter means the absolute shortest distance possible around a shape. That would be the distance you'd get if you trace the path exactly around the border or edge of a shape. A good way to see what perimeter is to imagine that you could walk right along the edge of a shape, like this 5-sided polygon. Imagine starting at one of the polygon's vertices and then walking along each side until you got all the way back to the point that you started from. The total distance you traveled would be the perimeter of that shape. In this case, if the length of each side of the polygon was 10 meters, the total length you would travel along all 5 sides would add up to 50 meters. Another good way to see what perimeter is to imagine that you could take a shape, like this square, and break it at one of its corners. Then you could unfold the shape until it formed a straight line. The length of that line is the perimeter of the shape. Doing this helps you understand why perimeter is a one-dimensional quantity, even though it applies to two-dimensional shapes like this square. It's one-dimensional because it's the distance of the lines that go around the two-dimensional shape. Okay, so now that you know what perimeter is, how do we measure or calculate it for different geometric shapes? Well, that depends on the shapes. Finding the perimeter of shapes that have curves, like circles or hearts or things like that, can be tricky. In fact, we'll wait and talk about the perimeter of a circle in another video. In this video, we're just going to focus on how to find the perimeter of polygons. Since polygons are made from only straight sides, it's easy to find their perimeter. If you know the length of each side, all you have to do is add them up, and the total length you end up with is the perimeter of the polygon. Let's try doing that with a few examples so you see how it works. The first polygon we'll try is a triangle. This triangle has 3 sides that are each a different length: 3 centimeters, 4 centimeters, and 5 centimeters. Now, to find the perimeter of the triangle, all we have to do is add up the lengths of those 3 sides. 3 plus 4 plus 5 equals 12. But don't forget, it's not just 12, it's 12 centimeters. Always remember to also put down the units of the perimeter. Okay, that was easy. Let's try another one. This time our polygon is a rectangle, and you can see that the shorter sides are each 5 meters long, and the longer sides are each 10 meters long. So let's add them all up. We can add up the sides in any order we want to, as long as we don't forget any sides or accidentally count any of them twice. And I think I'll add up the 2 short sides first. 5 plus 5 equals 10. Next, I'll add up the 2 longer sides. 10 plus 10 equals 20. And now, if I add up those 2 answers, I'll get the total for all 4 sides. 10 plus 20 equals 30. So, the perimeter of this rectangle is 30 meters. You thought I was going to forget my units, didn't you? Not this time. Here's another good example. This is a 6-sided regular polygon. A regular polygon means that all its sides are exactly the same length. And that's good because this diagram only shows the length of one side, 4 centimeters. But since the polygon is regular, we know that all the other sides are also 4 centimeters long. Now, we could just add up all the sides like we did before, but since they're all the same, we can use multiplication as a shortcut. That's because multiplication is really just repeated addition. All we have to do is multiply the number of sides, 6, by the length of the sides, 4 centimeters. 6 times 4 equals 24, so that means the total perimeter must be 24. 24 what? Oh, centimeters. That's better. Oops. And this formula works for any regular polygon, no matter how many sides there are. If the sides are all the same length, you can just multiply the number of sides by the side length, and you have the perimeter.
All right, so I'm going to pause him there and get back to our math lesson. And so on the next page, we are going to draw conclusions. They don't give us a picture, but I am a very firm believer in drawing pictures to help us visualize what it is that they are asking us to do. So it says to describe how you would find the perimeter of a rectangle that is 5 units wide and 6 units long. So I'm just going to draw a rectangle here, and I'm going to label my units that they gave on the sides. So the sides would be the width, and it said it was 5 units wide. So both sides would be 5 units wide. And the length is how long the shape is, and it was 6 units long. So that would be both the top and the bottom. So now we can kind of visualize better. In order to find the perimeter, which is the outermost part of the shape, we would add up all of the sides. And if you forgot, my handy little song is over here. You know, perimeters around. Oh, oh, don't you know, perimeters around. You add up all the sides. You add up all the sides. Oh, oh, don't you know, you add up all the sides. Promise I won't sing it throughout this whole video, but be glad we're not in class because you know I would make you sing this song along with me. All right, so we're just going to simply say add together. I hate that this makes my typing so big at first. Add together 6 plus 6 plus, whoops, 5, oh my gosh, 5, why are you doing that? Plus, I was hitting the caps lock button, not the shift. 5 plus 5 again, and what does that equal? Well, I know 5 plus 5 is 10, and 6 plus 6 is 12, so you can always break it down. And so we're adding 10 plus 12, which is 22. And we need a label, as we saw in the video. We need to label our answer to not just 22. In this case, we don't know specific lengths like inches, feet, miles, so it's just simply units. Okay, so this is how we would describe how to find the perimeter of our rectangle. All right, so our next problem is a think smarter problem. It says a rectangle has two pairs of sides of equal length. Explain how you can find the unknown length of two sides when the length of one side is 4 units and the perimeter is 14. So I'm going to draw out another image of a rectangle here just to help visualize what it is this problem is talking about. So with a rectangle, we know that top and bottom are the same length and the two sides are the same width. So if one side is 4 units, I'm just going to pick a side, let's go with the top, and label it as 4. And that means the bottom is also going to be 4 because we know opposite sides are equal. And so what would the two lengths of those sides equal? Well, 4 plus 4 is 8. And we know that the total perimeter around the shape is 14. So what we're going to do now is subtract the total perimeter minus the 8, which is the two sides that we were able to figure out. And 14 minus 8 equals 6. So that tells me the last two sides have to add together to be 6. It does not mean each of those sides is 6 because then our total perimeter would be much more than 14. So now we need to take the 6 and we're going to divide it in half. So 6 divided by 2 equals 3. So that means each of these other sides have to be 3. And to check this, I would add 4 plus 4 and 3 plus 3, and it should equal the total perimeter of 14. So let's do 4 plus 3 is 7, 7, and then the other 4 plus 3 is 7. 7 plus 7 is 14. So this worked out, okay? So we do need to explain that over here, okay? So let's say since one side is 4 units, the opposite side is also 4 units, okay? So that's how we got two side lengths. We knew one side was 4 and the opposite side also was 4. Then I subtracted 14 minus 8, which equals 6. Writing's kind of getting caught up in my work here. Oh, technology is so much fun. Okay. Then I subtracted 14 minus 8, which equals 6. Okay, and then lastly, divide 6 in half to get the last two side lengths of 3 units. 3 units each. And this might not be the best way to explain it, boys and girls. Maybe, you have another way of explaining it. Showing our work also helps to explain what we did. And so, that's why it's important to always show our work as well. Okay. In the book, I'll read the answer they gave, possible explanation. Since a rectangle has two pairs of sides of equal length, 4 plus 4 equals 8, then I subtract 14 minus 8 equals 6. Since the other two sides are also equal, I divide by 2. 6 divided by 2 equals 3, so the unknown side length is 3 units. Okay, so I think we did a pretty nice job of answering that question. All right, moving on to number 3, it says to evaluate. Jill says that finding the perimeter of a figure with all sides of equal length is easier than finding the perimeter of other figures. Do you agree and explain? Well, I remember in the video, the Math Antics video, the guy was talking about regular polygons, and when all of the sides are the same, we don't actually have to add them up every single time. Like the hexagon had 6 sides. He didn't add up 6 different numbers. He did a little shortcut. So when all of the sides of a shape are the same length, it is a little bit easier because we can use multiplication. We can take the number of sides the shape has and multiply by the measurement. So I would agree. So I'm going to say yes, because you can multiply the number of sides times the side lengths, or times the side length. Well, no, lengths, because there would be more than one. Okay? So whenever a shape has all equal sides, let's say it was a square and each side was 4 inches, then we could just multiply 4 times 4 instead of adding 4 plus 4 plus 4 plus 4. So that's kind of an opinion question, but I think it is easier when all of the sides are the same. All right, down below, making connections. It says you can also use grid paper to find the perimeter of figures by counting the number of units on each side. Start at the arrow and trace the perimeter. Begin counting with 1. Continue counting each unit around the figure until you have counted each unit. So grid paper is very similar to dot paper or using a geoboard. You can see how each time you connect like a side of the little squares, that's counting as 1 unit. So let's count across this rectangle and find the perimeter. So I just traced 1 unit, 2, 3, across the bottom, 4, 5, 6, 7, 8, up the other side, 9, 10, 11, 12, 13, 14, 15, 16. So a perimeter of 16 units. Okay, and that makes sense because if you have 3 on each side, and across the bottom, we had a total of 5. And so if you checked by adding around, 5 plus 5 is 10, 3 plus 3 is 6, 10 plus 6 is 16. All right, let's go to letter B and find the perimeter of this shape. So here's 1 unit, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So for this particular shape, it has an area of 14 units. Here was 1, and then we did 2, and then we came down 1, across 1, down 1, across 1. We came up 3, and then we had a 4 across the top there. So 1 plus 2 is 3, 4, 5, 6, 7, plus 3 is 10, plus 4 more is 14. Gets a little tricky when you have little stairs like this or upside down stairs, and you have to make sure you count each little zigzag part. All right, over to the next page here, the share and show. We need to find the perimeter of the figure, and this time it tells us that each unit is 1 centimeter. So now when we label, we're not going to be labeling in units, but instead we're going to label in centimeters. All right, so let's count the units, and you can go any direction you want. I'm just going to kind of go clockwise, I guess. So 3 across the top, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 centimeters for the perimeter of that polygon that looks like the letter T. Number 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 centimeters for that shape. That had 6 sides, so it's a hexagon. All right, this next shape looks like a square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 centimeters around the square. And then for the rectangle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. And for the rectangle, since we counted 2 down one side and what did we count? 1, 2, 3, 4, 5, 6, 7 across the top, we could have just stopped across the top and the side and just added double. 7 plus 7 is 14. 2 plus 2 is 4. 14 plus 4 is 18. So there are some shortcuts you can take when you are dealing with some quadrilaterals that have opposite sides the same. All right, so number 5 doesn't show us a picture, but we can still find the perimeter. It tells us that a figure with 4 sides measures 4 centimeters, 6 centimeters, 5 centimeters, and 1 centimeter. What is the perimeter? So we just need to add all those numbers up. We know we're only adding those 4 numbers because the shape has 4 sides. So I know 4 plus 6 is 10, plus 5 more is 15, plus 1 equals 16. On number 6, it says a figure with 2 sides that measures 10 inches. So 2 sides are 10 inches. And then one side measures 8 inches and one side measures 4 inches. We need to find the perimeter of this. So don't be tricked here. 2 sides measure 10. So that's 10 plus another 10. And then one side measures 8 and one side measures 4. So we're adding all those numbers up. So you can break it apart. 10 plus 10 is 20. 8 plus 4 is 12. And then 12 plus 20 equals 32. Okay, so that one kind of tricked us a little bit because it said 2 sides measure 10, so we had to double that. All right, number 7 says to explain how to find the length of each side of a triangle with sides of equal length and a perimeter of 27 inches. So we know that a triangle has equal sides, 3 sides, and it says that they are equal. So this would be an equilateral triangle. And if we know that the perimeter is 27 inches, we're simply going to take the total perimeter and we have to divide it by 3 because there are 3 sides in the triangle, and that would equal 9. And so 9 inches would be the length on each side. Okay, you don't have to write words to explain it. If you kind of show your work here, that would be enough to explain how to find the perimeter. Each side would be 9 because 9 plus 9 plus 9 is 27. All right, so on this problem, Louisa drew a rectangle with a perimeter of 18 centimeters. Select the rectangles that Louisa could have drawn, mark all that apply. And so if we know her total perimeter is 18, remember that means the total distance around, adding up all of the sides, and if it's a rectangle, we would be adding up 4 sides. So I'm just going to draw a rectangle. It doesn't really match up with the grid or anything. That's not going to matter. But we need to test out some options and see what could work for Louisa. So if it was 9 centimeters long and 2 centimeters wide, what perimeter would that equal? Well, we would do 9 plus 9, which is 18, and 2 plus 2, which is 4, and 18 plus 4 is going to be more than her perimeter. That would equal 22, which is too much. So it can't be letter A. All right, so then letter B says 6 centimeters long and 3 centimeters wide. So if it was 6 centimeters long and let's say 3 wide, 6 plus another 6 would equal 12. And then 3 plus another 3 would equal 6. And what's 12 plus 6 for our total perimeter? Well, 12 plus 6 equals 18. So this could be the rectangle that Louisa drew. Let's see if there's any others that work. 4 centimeters long and 4 centimeters wide. So in this case, that would mean all 4 sides of the rectangle are 4, and 4 times 4 is 16, not 18. So that option wouldn't work. On letter D, 5 centimeters long and 4 wide. So something like this, and 5 plus 5 is 10. 4 plus 4 is 8. So when we add the total perimeter, that would equal 18. So that could work for our rectangle. And the last option, 7 centimeters long and 2 centimeters wide. So 7 and 2. 7 plus 7 is 14. 2 plus 2 is 4. And when we add that together, that would equal 18. So that rectangle could work as well. So B, D, and E. All right, down to number 9. What's the error? Kevin is solving perimeter problems. He counts the units and says the perimeter of this figure is 18 units. Okay, well, he made a mistake, and we need to figure out where he made that mistake. So it looks like he started counting over here on the left side. So I'm going to count with him. 1, 2, 3. And then he goes over here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then he jumps up here, 17, 18. So anyone spot his problem? What did Kevin not do? Kevin did not count all of the sides in the figure, right? He missed a couple sides. And they want us to circle the places in the drawing where he made an error. So he missed right here, and he missed right there. So if he thought his perimeter was 18, but he forgot to count 2 sides, he got a perimeter of 18. What is the actual perimeter going to be? Well, without counting it, I can add 2 more sides that he missed onto 18 and get a total of 20. But I do want to add just to be sure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so he did not add up all the sides. He skipped over 2. That's why when you are finding the perimeter of these odd-shaped polygons, I do suggest to trace and count the outside with your pencil, or cross off sides as you're adding them so that you don't add anything twice or forget to add something. Okay? All right. Over to our practice and homework pages. This is the home stretch of the lesson. Finding the perimeter. Each unit, they tell us, is 1 centimeter, so that helps us with our labels. They did the first one for us and got 22 centimeters. This next shape is a rectangle, so I can count across the top length. So that would be 1, 2, 3, 4, 5, 6. So if the top is 6, I know the bottom will be 6. And then down the side, 1, 2, 3, 4, 5. So if this side is 5, then the opposite side is 5, and that can help me get the total perimeter. 5 plus 5 is 10, 6 plus 6 is 12, 10 plus 12 is 22. They ended up being both the same. 22 centimeters for the perimeter. All right, on the problem solving, what is the perimeter of Patrick's figure? So Patrick drew this quadrilateral, and let's see, 1, 2, 3, 4, 5. So that means the bottom is 5. 1, 2, 3, 4, 5. Oh, he drew a square. So if all 4 sides of his shape are 5 centimeters, what would be the total? 5 times 4 equals 20. And don't forget your label. We can do cm for centimeters. All right. How much greater is the perimeter of Jillian's shape than the perimeter of Patrick's? Well, we don't know the perimeter of Jillian's shape, so we need to figure that out. So let me go to a different color here, and let's go 1, 2, 3, 4, 5, 6, 7, 8. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8. Yep. 9, and then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I got a perimeter of 22 for hers, and we know Patrick's perimeter is 20. And so how much greater is Jillian's? Well, the difference between 22 and 20 is just 2 centimeters is what we're talking about. Okay? We're going to skip number 5, the write it, and just go straight over to our next page. Lesson check number 1. Find the perimeter of the figure. Each unit is 1 centimeter. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 centimeters. So we need that label. It's important to know what our units are. This next shape is kind of odd looking. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I always like to double check in the answer book just to make sure. And centimeters for our label. Spiral review, order the fractions from least to greatest. Ooh, tricky because we see the top numbers are the same. I see numerators are all 2s. So then we can compare the denominators. Now, remember, boys and girls, typically when we're comparing numbers, we look for big numbers are greater, small numbers are the least. But in this case, with our fractions, the bigger the denominator actually means the smaller the pieces. So if we're looking for the smallest, the least fraction first, we're going to start with the one that has the bigger number on the bottom because that actually means those pieces are smaller. So 2, 6 is going to be our least amount. And so then 2/4 would come in the middle. And the greatest would be 2/3 because that says that the whole thing, like if you think of a pizza being cut into only 3 pieces, those pieces are going to be much larger than the same size pizza that was cut into 6 pieces. So we have 2/6, 2/4, 2/3 from least to greatest. All right, number 4, Casey's school starts at the time shown on the clock. What time does Casey's school start? Remember, the shorthand tells us our hour, and it's between the 8 and the 9, so that means we're in the hour of 8. Put your colon for our separation of the hours and minutes. And if your minute hand, the long hand, is straight down on the 6, remember we count by 5s around the big numbers. And we're halfway around, so that would be 8:30. Now in this case, we could add a label because if this is when school starts, we would know that this would be happening at 8:30 a.m. And then comparing our two fractions, this time they have the same denominators, so we simply compare the numerators. 4 out of 8 is going to be greater than 3 out of 8. And lastly, Aiden wants to find the mass of a bowling ball. Remember, mass is how heavy something is in our metric system of measuring, and we measure in grams or kilograms. If he's measuring the mass of a bowling ball, he's going to measure that in kilograms. Remember, grams are like grapes, kilograms are more like pineapples. So definitely kilograms for a bowling ball. All right, guys, I hope you understood this lesson. If you have any questions, please reach out to me. Tomorrow's lesson is still on perimeter, but we're going to be doing some measuring of the shapes, so you will need a ruler. It looks like an inch and a centimeter ruler. If you don't have a ruler at home, I would definitely tune into the video and you can follow along with me. And if not, reach out to me and we'll come up with another solution. All right, I hope you enjoyed Sadie's little cameo appearance, and Noah kind of rolled in during the video on his skates and quickly rolled on out. So anyways, guys, hope you're having fun at home. I will talk to you soon. Bye.